Thanks for joining us again today for this new webinar hosted by NextDent and 3D Systems. We are very excited today to release the newest update to our 3D printing software, 3D Sprint version 2.13. When you launch your 3D Sprint software in a few hours, you will be prompted to download and install the update. After the update, you will also receive a notification to download the latest material database. This material update patch contains the Model 2.0 gray and peach build style for stacked printing. This immediately showcases a new feature for the new 3D Sprint release, the automatic push notifications when there are new material database patches available. For example, new build styles and/or new support styles. During this webinar, we will show you the most important new functions that are applicable for our NextDent 5100 users. We will cover some software functions, build and support style changes, and of course the new main features of this release. All these developed specially for our customers to improve the daily workflows and increase production on your NextDent 5100. We will kick this webinar off with Menno Pot, our Senior Application Specialist at NextDent, who will demonstrate the 3D Sprint version 2.13 update. At the same time, we have Lars Biel, also Application Specialist at NextDent at our training center in Soesterberg in the Netherlands, who will show you live the impact of the changes in 3D Sprint on the printed parts. Like always, I encourage you to use the Q&A functions of this webinar to post any questions that come up during the presentations. And of course, we will make this webinar available on our YouTube channel and social media shortly after. With this, I would like to hand this over to Menno. So Menno, if you unmute, you can start sharing your screen and you can take it away. Thank you.
Okay, Stijn, thank you very much for this introduction, and welcome everybody to indeed the launch of our latest software 2.13, where we have some very interesting features for all of you in dental. Well, first of all, I would like to start with something that we call keyboard shortcuts. And as you know, in a lot of software packages, you can make use of these shortcuts or hotkeys. And what we did for you now is that we just made it available for you here. So you can just click on it and then you will be prompted to an overview of all these hotkeys. Now, I'm not going to take you over all of them. I'm just going to demonstrate a couple of them. Let me remove this here. But by clicking on it, as you can see an overview of all these hotkeys. What I did personally, I just copied it and I printed it out, have it laying next to my computer so I can get familiar with it, and at some point you of course know them by heart. To demonstrate, I would like to first get a part into place, and that is done by the usual way, by selecting your printer, the NextDent 5100. And then in this case, I would like to select the surgical guide. By selecting something in 3D Sprint, it becomes blue, as we all know by now. For those who are not familiar with the functionalities, the basic functionalities, we did a webinar earlier this year, I would say, and that could be watched on YouTube. So if you are not familiar with some of the steps, then I would like to advise you to go there. Once I've selected, I can then go to the file, import, and then I have to go to my desktop and select the surgical guide that I want to use for these things, for this demonstration. First of all, you have, of course, some of the keys that were already there, and one of them is the auto place. Auto place will fit the part in the middle of the platform. As you all know, we have some functionalities here like transform with the move, rotate, and scale. This can now be very easily accessed by hold Q. So you just press Q on your keyboard, hold it, and there you have all the functionalities that you would normally have with transform. So now you don't have to actively click here and then move your part. You can now just use hold Q, and then we have all the functionalities you need for rotating this part. The only thing for dental I would like to make you aware of is these balls. they are the scaling ball. So if you use this by accident, you will scale the part, which is of course something we do not want. If you by accident did this, you can just click the undo, and then we have everything back into the normal properties, I would say. This is one of the keyboard shortcuts that I would like to use. The another ones are the Alt 1 until Alt number 7. That makes you rotate your virtual platform. So by clicking Alt 1, you can now have the top view, Alt 2, bottom, and then so on. You can have a lot of different orientations. Normally you would do this here. Of course, this is still something that could be used, but now we also have the short keys for that. Another thing I would like to point out is the toggle clipping plane. Sometimes it's useful to go through the part to see where something is thick or thin. And now by clicking the X, Y, Z, you will have the possibility of opening the feature that allows you to go through the STL file to the surgical guide part in this case. Click once, you will have one view. Click second time, you will have the other view. And I'm now using the X, but the same can be done with Y. So I can now go up, down. Again, if you click it the second time, you will have the other side of the part. And if you want to close it again, just select this. Now, there are a lot of opportunities here. Like I told you, just click here. You go to the overview. I printed it out, so I have all the options available next to my laptop in this case. Now, this is one of the new options, and then I would like to continue with actual surgical guide, because surgical guide we have a change as well. We have a new supports for the surgical guides. We have called it fine tip. Some of the customers felt that the support now available are quite thick, robust, left a lot of support scarring. So we set together with the team, the application team, the engineers for the software, 3D Sprint software, and our print process guys said, okay, can we make this as reliable as, but thinner supports? And we could. So what I would like to do first is orientate the part in the correct way. So hold Q. I can just flip it like this. This is the orientation that we advise you to use when printing surgical guides. Okay. Then I would like to have a second one in there. So I'm just rotating a little bit more so the second one can also fit on the platform. And this can be done by using the copy function. Select your part, click set, and there we have the second part. Of course, as we can see, it's not in the right direction. You can hold Q or use the transform option. I'm using the hold Q, and I will make it larger again. So now I'm going to support one of the parts with the general support style that we have, create supports. And then the other one, select it, smart support. And here we have the second option, which is the fine tip, create the supports. And hopefully now you will be able to see the difference between these two supports. And that can especially be seen on these supports here. If you look closely, you can see that these pillars are thicker than the pillars we have here. And also in the back, I think we can make it visible that these are somewhat thicker than on the left side. On the left side, we have the fine tip. Here is the general. Now, what does this mean in practice? And that's why we are going now live to Lars, who will demonstrate and will show you what actually is the difference between the two support styles in practice. So Lars, it's up to you now.
Okay, thank you, Menno. As you can see, I've printed here a surgical guide with the new support style. And the new support style makes it quite easy to remove. The older support style, you still had to really break them off, but now just a little bit you rotate and you just take the supports off. The new support style has decreased the support scarring. As you can see now in the screen, you have the old support style where the support scarring was quite heavy. And on the right side, we have the newer support style where we decreased the tip size and the pillar size to make a smaller support and less scarring. So back to you, Menno.
Lars, was quite clear to see that there were two different support styles altogether. The second thing I would like to explain today about the 2.13 software is that we have a new print mode for the castables. So in order to show you that, I'm going back to my printer again, select the new material cast. Then we have one color, and here we have the difference, the 30 micron and the 50 micron. I will now first demonstrate the 30 micron and then set. We can import the file. I have the nice part here. Just open it and there we have it. Now, first of all, I like to use autoplace to just put this in the middle of the platform. And then we can hold Q again and rotate the part in the direction that we want to print it. We want to make sure that this part is as close to the platform as possible. That will save you some printing time. Of course, we have to use our smart supports. Create supports. And this is a very short demonstration, but the thing is that by changing the layer thickness, we have now a faster build style for cast with the same accuracy, of course. You can see now that when I selected 30 microns, the time estimation is 42 minutes. And if I go and change that, oh, I have to do that here. I change it to 50 microns. It will ask me to change support, but nothing really happened there. So I'm going to discard that. And then I click the estimate and you will see that we have a totally different time estimation now. It was 42 and it is 19 minutes now. So that saves you a lot of time and the part quality is still the same. And to explain you a little bit more in detail what that means in practice, again, we like to go back to Lars for a brief moment.
Thank you, Menno. Again, here I have some cast parts in my hand. I actually printed them just now. The supports on cast are so small that you hardly have to break them away. We made them so small that the support would always be weaker than your weakest part of your RPD. So in the screen now on the right, sorry, the left, you see the 30 micron layers. So it is really difficult to see the nuances between the 30 micron build style and the 50 micron build style are quite small. You can see them when you really focus on them. Another important thing to know with cast is once you wash them and you clean them, you air dry them directly with compressed air to make sure that they're completely dry, and then straight away put them in the curing box for 5 minutes. This makes sure that there will be no warpage during that time from cleaning to the cure box. Thank you. Back to you,
Thank
Menno.
you, Lars. Thank you, Lars. Very clear. Also good instruction about going to the cure box right away. Menno, if you are ready, you can share your desktop again, and we will continue to the next topic. So far, we have no questions regarding this or the two topics that we already handled, so we can just continue with our next topic. Thank you.
Okay, Okay, so yes, we will continue. I already selected my material for the next application that we want to show you because we have some interesting news we want to share about NextDent denture 2D Plus. So again, I will select the material. In this case, I will use the pink, and then we have set anything. Yes, we want to, because this is not a denture, we get rid of that. And then, of course, we import. First of all, I would like to start with, let's say, the lower. And here we have the lower. And let me see. Again, autoplace, because then it is in the middle of the platform. The print orientation for these dentures, we have looked at that with our application team a long time. We've printed hundreds of dentures. And why is this? Because the denture basis, of course, we have to have a good balance between the accuracy of the tooth pockets, but also, of course, of the part that actually goes on the gums, the mucosal side. So we have done a lot of testing, and we found that a orientation of 60 degrees like this, and I will use the transform option now because then it's somewhat easier to explain. If you have a orientation of 60 degrees, and I will tilt it one last time, it now says 70 degrees, but that was because the part was already tilted a little bit. This orientation is the preferred orientation for dentures. I will demonstrate the upper later on. And we've also found that by creating support bars, you will have a more stable, robust build, and therefore a little bit more accuracy of the end part. Now, we're not talking about huge differences. The current build style works perfectly fine, but we are aiming to achieve the highest possible. And we found that by creating support bars, it will get a slightly more accurate end part altogether. Now, this is the next new function of the 2.13 software, the create bars. Normally, you would have to create bars by first creating a geometry. It's possible, but it's quite time consuming, I would say. And now we have this option, which makes it really easy. Now, for the lower, we found that we need 2 support bars and 1 bar connecting them. And we will now use this option to create those support bars between what we call the trigoni is 1 dot here, 1 dot there, apply, and you see that we have a support bar. The second support bar will be placed between the second premolar and the first molar, so that would be about here. Apply. And then if we connect those like this, this will give you a robust build throughout the printing. Printing is done in layers, as we all know, and this way we can now have a stable and robust build, making the end part slightly more accurate. Now, the same can be done for the upper. So if you do this, then the supports will follow. So I will also take the upper. We will put that in the right position, of course. Let me see. Drag it in there. You can see it's quite high. That's not what we want. Rotate it. See, yeah, that's okay. And then we can use the transform option. Select the part, rotate it. And you can see that it started at 360, so 60 degrees will be 300. Now we can create the support bars. And for the upper, we found that 2 support bars on this side, the tooth fitting surface, I would call it. One near the posterior border, like so. connect that to also the base itself here. So we get a kind of a T section. And a second one also between the first and second molar. So here. Also this one will be connected like that. Very important and different from the lower one is that we also need to generate some support bars here on the inside of the denture. And the first one, we will do this here. It's, I would say, near between the cusp and the premolar. So we place it here, just on top there, and the second dot there. Again, apply. And we also found that it makes a slight difference in accuracy. Again, the accuracy is already good with the normal build style, but if you place the supports like so here, it will be a more stable build and therefore a slightly more accurate part. So we've placed all the supports, which is now very easy with the create bars option. It's just a matter of seconds. If I do this, let's say, away from this webinar, it's just click, click, click. When you know where to place it, it will take you not more than a minute, I would say. We also changed the smart support style. We have the general one, which can be used currently, and there will be a new one coming. It is not available yet. We are working on this still, but this is a slightly more stable support. I will show you the differences, or at least I will show you what is new about this support style. There we have it. So this support style is also, let's say we have some scaffolding in between these higher pillars. We found that the normal support style, these pillars were quite high and not connected, and therefore not so stable during the build. So now this new support style will have it's more robust. The supports are more robust during the build, but they still have the very, very fine tips that we need, because a lot of people think, hey, this is not what we want. We do not want these supports on the inside of our denture. Now, in fact, on the inside of the denture, we actually only have 4 supports here, and they are very, very, very small. So that's what we have done for the dentures. And if you print it like this, you will have a good fitting denture, stable, both sides. The fit in the oral cavity on the mucosa will be very nicely, but you are also able to fit your arch or your teeth perfectly fine in these sockets. Okay, then I think we are going back to Lars for a moment.
Yes, Lars, you ready?
Yes, I'm ready. So here we have a denture. I already glued the teeth in there, but I kept the bars during post-processing. So we will quickly show you how easy it is to remove these bars. So you just take a normal carbide tool, you start grinding them away. So while grinding them away, the smaller tips makes it easier to grind them away. So now you have the denture here. Oh, so there. So now you see that there's still parts there, and they're quite easy to remove and flatten with your normal hard carbide tool. And doing this and feeling if they're totally gone. Be careful that you don't grind too much away, because you still want that good fit. So once you grind them all away, you can actually straight away go to the polish machine, or maybe take a rubber to smooth them even more out. And then once you polished the denture, it kind of looks like this. So thank you, Menno. Back to you.
All right, thank you, Lars. Menno, we bring it back to you if you share your screen.
Yeah, should be fine now. Okay, thank Thank you, Lars. Yes, these support tips are very easily removed. So we've made several now. Of course, we've tested this. And now that brings us to our last part, I would say, of the webinar, but certainly not it's, for me, it's the most exciting one. And this kind of proves what you can achieve when software engineers from 3D Sprint, print process people, and dental application come together. Because we're going to talk about stack printing now. And for that, we first have, of course, to select the printer again. We select the model material because stacking at this moment is only available for orthodontic models, and also available if you upgrade your software at the moment in color white, but like Stijn explained in the beginning, the gray and the peach will be available later on today. So you will be able to print the stacks in all the available colors. For now, I will stick to the white. And here we have it. We have the orthodontic, prosthodontic, and this is the new one, orthostacked, optimized for automatic nesting, hollowing, and placement of orthodontic models for single and multiple stacked levels. So once we've selected that, as always, you can see this here on the right lower corner, the printer, the material, etc., etc. And now, of course, we have to select the correct file for that. We have set up a stacked demo file for you, which is actually an aligner case. Aligner cases, they look quite similar, of course. All these models have small details that are different. And if you take those models here, then you can see that it looks like 2 models, but in fact there are 24 models. But because they are so similar, you cannot see this at the moment. So 24 models, and the only thing you have to do now to create the stack, to hollow this model into a 2 millimeter wall thickness model, hollow model, to create a support style and to print it, is to select the stacked arches and click apply. Now, and what will happen is that it will now calculate the best orientation for each of these 24 models onto your platform. Normally that would be, let's say, in the direction, not in the length of the platform, but in the width of the platform. If a model is too wide for this, then it will also orientate it such that it will fit. It will hollow the parts 2 millimeter wall thickness to make it more stable. And what it will also do is create a what we call a lattice structure. And that will be shown briefly. Of course, it takes some calculation at 77%. So hopefully it will be reaching 100 soon. And then you can see that this is a very cool feature that we have made here. It is now placing 24 models in one go. And we'll take a couple of seconds more, and there we go. And here we have the stacked option, which 24 models stacked perfectly. You can see that we make use of the Z axis, the height of the NextDent 5100 machine. Although we have a rather small platform, which is normal with DLP-based systems, we have now made use of the bigger Z height. And with this stacked feature, you can now print up to 30 models in one go. It of course depends on the size of the model, and this will be different each and every time. We work in dental, nobody is the same. So but for this example, we have a case, again, an aligner case of 24 models. And if we go in there, we enlarge it a little bit, you can see that here we now have the wall thickness. We can measure that if we want, and that will show you that it's 2 millimeters. What is also is done that it's not only stacked, but it's now connected with these support bars, these bigger support bars. And these, of course, they make the connection between the parts, but they also make for a very stable print during the printing. This is very stable. The shape is made such that it is stable throughout the printing process. But if you look closely, you can also see that they are what we call notched. And this means that after printing, they are very easy to remove. Now, you also see that there are some other supports here. And we can make this more visible here. These supports are placed on the anterior side of these teeth. And you can see there's a slight difference between the models. That is also because the models, they are slightly different from each other. It also has to do with the placement along the stack. And some people say, well, is this something that we want, supports here for an aligner case? If you ask me, yeah, maybe not, but these are there for a reason. You cannot print in open air, is what I always tell people during trainings, etc., etc. And these are there to support these teeth, the layers that we print in, to prevent them from collapsing. So yes, we could take them away, but then the overall accuracy of the model will be less. And this is something that you cannot see with the naked eye. So I have had people say, well, the model looks perfectly fine now, but yes, you cannot actually see the accuracy. Now, we've tested this. We've been working on this for a very long time. And in the end, we found that, yes, we do need the supports here to make the overall quality, the overall accuracy of the part good enough and predictable in each and every of these models in the stack here. And what we did, we made these support tips as small as possible. Now, a small tip from our side is that if you have printed it, remove these supports before post-curing, and you will actually almost have no support scarring whatsoever. So these little supports, you will not even see them. We go to the other side of the model, and what we see here is next to the hollowing that we also create what we call a lattice structure. And the lattice structure is a honeycomb structure almost, that makes the print, the model, stable during printing, because if you create a stack this high, you want the first model to be as accurate as the last model, and that is why we created this lattice structure. It helps during printing stability in a similar way that the create bars would do, but this is now fully automatically generated for each and every model. It also allows you to have a very stable model after the print process, but if for whatever reason you do not like it, it's also very easy to remove afterwards. And that will be demonstrated by Lars in a few moments. Now, when we have the stacked arches, we do have some options here. I would like to say just use the default settings. But if you want to change something for whatever reason, you can. This is done here. And I can show you by some slides from a PowerPoint what the differences will be. So for instance, you have the option to create some more space between your models, and that will look something like this. Then you have the difference between 2 millimeters and 10 millimeters arch spacing. That's fine by me, but of course, then your models will be higher, placed higher up on the platform, and that means that you will not be able to print 24 models, but 18. And we have another option that you can change, is that the space between the actual models here in the Z-axis. And if you change that, of course, I took the minimum and the maximum to make it quite obvious. You see that there's more room, but again, you can print far less models. Another thing that is important that I would like to show you is that you can change the point influence radius of your support tips. And if you make this higher, so you go from the default setting is 3, if you go from 3 to 6, you will see, or from 1 to 6, sorry, you will see that there will be less supports. But again, we advise you to use the default setting because these supports are there for a reason. Now, why am I showing you all these parameters and then telling you actually not to use them and use the default settings? This is quite simple because these settings will come into place when we will bring you different types of stacking. In the future, we will hope to have denture stacking or some other application. And that might mean that some of these applications that you can find here might be slightly different for that particular application. Now, this application, this stack can be printed 24 models in less than 2 hours. And after the printing, and this is where Lars comes in again, you can very easily clean them, remove them, etc. So Lars, please show us how easy that is done.
Okay, Lars. Yes,
Thank you,
you're good to
Menno.
go.
So I have a stack printed here. So that is one of the stack that Menno is showing. As you can see, this is still all connected. So I washed them all together and I post-cured them all together. So to break these off, it's actually quite easy. They just come off. They just snap clean off at the notch, the point where we made it weaker, just because then you can easily do that. The lattice itself, so you can see that there in the back. So if you don't like it, it's actually quite easy. You just take your thumb and you push it out. And your lattice is gone. You could still take your tool to remove all the sharp edges. So when you look at the next model, now there's the connectors are still there. Also those, you break them off really easy. You can snap the next layer off again and remove the lattice structure. So that's how easy it is to break them away and to remove the lattice structure. That's it.
Very nice, Lars. Thank you for your nice showcase. So, Menno, do you have some other things to discuss, or should we take it to some questions?
I think we can take some questions. It's actually all I wanted to tell you for now on the new and improved software.
All right, very nice. We received quite a lot of questions, so I'm gonna go through the ones that we want to discuss in the group here. One is related to the partial frames. So we go back to the partial frameworks, the cast material. There's somebody that says, well, I don't always have a good fitting. And sometimes it stands up a little bit, he says. So what can we say to advise him? There are a few things. One most important thing I think you already explained is that you post-cure it, or Lars explained it, post-cure it immediately after printing and washing. That is one important thing. What kind of investment materials is another question that comes up here. Can you say something about that, Menno?
Yeah, that's a good question, and a question that we get quite often. First of all, when printing the cast, of course, you have to make sure that the parts are not too thin. And like Stijn told you, that we found that the post-processing of the parts is very important, that you do this immediately after printing. For instance, if you print the part, you leave it for a couple of hours, come back, then you will see some warpage. So we found that after cleaning, drying the part, so make sure that there's no alcohol or IPA left on the part, then post curing it, then the fit will be best. And what investment material to use? Yeah, that's a good one. We have tested 3 investment materials which you can find in the IFU belonging to the cast material. And the cast material, the difference is that it is of course not a wax. So if you're going to work with our castable material, make sure you have an investment material that can take the expansion rate of our material, because it is different from wax. So if you have a material that you have been using for, let's say, 20 years with wax, and you switch to our cast material, you might be surprised and not succeeding. So take a little bit of time to look into our IFU. There you will find, again, 3 investment materials that we tested. I know that there's a lot of investment materials out there, and I'm sure that there will be more that will be suitable, but you have to play around with the expansion rate of that particular material to make it work.
Yes, thank you. Additionally, I might want to ask, because there was also some remarks about the curing boxes. So all our testing, of course, has been done with the LC3D print box from NextDent. If you use another curing box, chances are that it works, but it's not a given. So yeah, and then we can also not really comment on that, of course, because of course the light intensity has a big role here, but also the temperature, especially for the cast material. So that is a good thing. We stay with the castable material. It's a good question. Is the support bar function that you showed the Denture 3D Plus, is it also available for castable material? That's a good question, Menno.
I think that's meant that if we want to create a support bar in 3D Sprint, yes, it will be available there. As a matter of fact, we can look at this, because I have, to be honest, not
We haven't tested it. Of course, we also use it for models, and it's made available for all the different materials. It's a standard function of 3D Sprint. But Menno, it's nice if you can share your screen again. Maybe we can.
Let me see what we can
together.
do here. It's always this upper open, and you can see that it is available. So very quickly, autoplace sets, create bars, and then we can see that if we click on this, it is available. So
and
yes,
you can make the bar a little bit thinner.
If you want, maybe. Yes, you can play with the width and the support tips. So if you want to have it a little bit thicker or thinner, you can play around with this, no problem. I must say that I normally do not use the support bars when printing my castable parts. It comes out just fine. I've learned that these bars were there for metal printing, but actually, of course, we're not printing metal, we're printing our castable parts. And I found that without the support bars, this works perfectly fine. But if you would like to use it, it is available.
Yes, very nice. A few more questions about the update itself. So the update will be made available normally in a few hours. We're just waiting for Eastern time in the US to start their day to roll out the automatic update. So it will come automatically when you start 3D Sprint in a few hours. You will receive the prompt or the message box asking you if you want to install the update. And after you have installed the update, you will also then get another question if you want to import or update the material database, which will include the peach and gray model style for the stacked printing. Another question, does it also come with the 3D or with the firmware update for the printer? No, not at this time. There is no firmware update that is coming together with this 3D Sprint update, although we do expect a firmware update in a couple of weeks, but this is then completely related to the user interface at the printer. The good question about the material, when we do stack printing, 24 models, and 24 is still a low number. We have seen stacks up to 40 models. The question here is the material tray enough for this amount of models? Can we put enough material in the tray? Lars, maybe this is a question that you can handle. I'm going to bring you to the screen. Just give it a second to transfer, and there you are.
Yes, actually, the material that we have in the resin tray itself, when you put it at maximum, is enough for all those models. That's also part of the reason why we hollow the models, so we have enough material in there to print, and it saves material for the end user in the end.
Yes, and actually I comment that recently we have been printing these ear protectors in stacked a lot, and we made a design which is very good position. So we have a full build. It was 96 of these ear protectors, and there we had to really fill it to the level 4, to the maximum, to be able to print it. Let's say so. Yeah, we can print the full volume. X, Y, and Z if you fill it up to the max, or just slightly overfill it. So that's a good question indeed. Let's take it back to the Denture 3D Plus. Lars, now that you're on the screen, I have a question about assembling the teeth and base. Do you do this prior to removing the bars and post-curing? What's the workflow on that?
Yes, I personally put the teeth in there before removing the bars, because you do create some heat and some like really a tiny bit of shrinkage during the post-processing stage. So it's better to keep those bars on until the teeth are glued on and done, and post-process the whole part in once.
Yes, nice. Somebody asks a question about the support bars again. Is the bar setting defined to the optimal parameters for each material? No, it's not. It's let's say a standard function, and you can change the diameter. We have optimized it actually for Denture 3D Plus because that is the most important application for it currently. But you can change it at your own willing, let's say. Question about surgical guides. Maybe Lars, also something that you can comment on. Sometimes surgical guide, the metal stopper ring does not fit. Even if there are multiple holes, it will fit in one and not on the other. Is this something that we have seen before? That if you put in a metal insert into the surgical guide, that the fit is not always the same?
In general, the fit should be the same or equal. In some cases, when the angulation is really big from horizontal, that could give a problem. That's why we advise you to have the holes from the sleeves as vertical from the platform as we can.
Yes, so the orientation is probably the biggest influence on this. So always make sure that you have the number of holes divided equally over the perpendicular direction to the build platform.
Yes.
Yes.
Menno,
I would like to comment a little bit on this because what Lars is telling is absolutely true. But we also have set some design parameters. So for both Exocad and 3Shape, we have some cement gaps, etc. So I would also like to point out that if you follow these parameters, these instructions, that will have is of course beneficial to your part fit. Next to that, and we touched base on that briefly, but all our things are tested in combination with the LC3D print box. I've seen people post-curing with different light sources, and that could have a negative effect on the fit. And of course, we're talking about very small details here. So I would like to point out, use the correct parameters, use the correct orientation, which you can find on our website, by the way, as well, and also follow each step that we have told you to use.
It's also helpful to put the metal sleeves in before the post-curing process.
Yeah, good point, Lars. Thank you.
Yes, and then it brings us to the post-curing. One more question about that. How long does the print box should be preheated before post-curing is the question. Now, first of all, definitely for cast material, not make it room temperature, or preferably not warm, because the slightly amount of wax in the material, is that correct, Menno? That could warp a little bit with heat. So we rather have this at normal room temperature, or can you comment on that?
Well, for cast, because it's of course not a biocompatible product, it's the only reason why we post-cure is to get it more stable. Otherwise, the part will be so flexible that in combination with investment material and stuff, it might deform a little bit. So for casting, it's not really necessary to preheat. You might be even better off, like Stijn just said, to use it in room temperature. For the other applications, it might be useful to just preheat it in the morning for 30 minutes, and then you're ready to go for the rest of the day.
Awesome, great. And to end, I think I'm not seeing. Oh yeah, there is one more question that just came in about what about other than Exocad and 3Shape? Well, yeah, on CADs, CAD software, Exocad and 3Shape definitely are the biggest ones available in the market today, but our printer and our software is of course open to any STL file that comes from any software or service provider, because we have a global partner called Global Dental Solutions, Global Dental Science, sorry, with Avadent. They can also give you designs that you can print in-house, and of course there are others like Full Contour and so many others. So yeah, it's of course our printer and our software are open for all these files. And then to conclude this webinar, the big question about Denture 3D Plus and the classification. So there's some questions about class 2A. What does that actually mean? Is this short term? Is this long term? Anybody that wants to comment on that?
That's a good question, of course. We have different classifications, such as Surgical Guide is a class 1 material, and the Denture 3D Plus is a long-term 2A classification. Long terms actually means that it can be inside of the oral cavity for up to 50 years. And that's of course not the lifespan of a normal denture, but it's just yes, a time frame set by the authorities. And the difference between a class 1 is that this is only allowed in the oral cavity for 30 days. So that's the difference between a class 1 and a class 2 medical device. There's a lot more to it, but this is in a very short briefing of these two classifications.
Yes, thank you very much. And as I understood, there is also some more post-market clinical follow-up and all that stuff involved. But of course, that's why 3D Systems and NextDent have a big regulatory and quality assurance division that takes care of all that stuff, and we can focus on the applications, right? So if there are no other questions coming in at this time, I would like to conclude the webinar for today. As we have said, you will be prompted for the update hopefully in 1 to 2 hours maximum, and immediately after you will get the material database patch for the peach and gray for the stacking solution. Of course, we are at your disposal. If you have any more questions, you can always ask them through our social media channels where we have posted these webinars as well, and the webinar will also be available on our website, on YouTube, and on our social media channels within a few hours, let's say. So thank you very much for spending this time with us. Thank you very much, Menno, again for this very good software overview, and of course Lars for the hands-on and in our training facility in Soesterberg, where hopefully soon we will be able to invite more people for live trainings, resellers, but also end users will be possible in some time. So everybody stay safe, stay healthy, and we hope to see you soon again. With this, I would like to end this presentation.
Thanks, everybody.
Thank you.